In question 2.1, we have the following graph where we define g of uv to be the weight of the edge between nodes u and v, and h of uv to be the value returned by the heuristic for nodes u and v. For Dijkstra's algorithm, the general procedure entails inserting all vertices into a priority queue, ordering them by distance from the source, and on each iteration, we remove the vertex with highest priority and update vertices pointed to by outgoing edges from this vertex, if the distance of the current paths to these vertices are shorter than what is stored. So we begin by initializing all the priorities of the nodes in the priority queue to be infinity. Since we're starting at vertex A, we set its priority to 0, since that is its distance from itself, and pop it from the queue. We then look at the vertices it is pointing to, which are B and D. The current distance from A to B is 1, and that is definitely less than infinity, so we update B's priority. Similarly, the distance between A and D is currently 2, so we update D's priority as well. The next node to pop from the queue is B, since it has the highest priority. We see that it is pointing to C, and the current distance to C from A along this path is 4, which is less than infinity, so we update its priority. Next we pop D. It's pointing to E, and the current path to this vertex has a distance of 5, so we again update. Next we pop C. The current distance to F is 6, and the current distance to G is 8, so we update both since they're both currently infinity. The next node to pop is E, and we see that it is pointing to G, and along this current path we have a distance of 8, but since G's current priority is the same, we don't update. Next we pop F. It is also pointing to G, and the current distance is 7, which is better than what is stored, so we update. And finally we pop G, and now we have the shortest paths from A to every other vertex in the graph. In question 2.2, we're going to run A star on the same graph, starting from A and with G as a goal, which takes into account the heuristics defined for each edge. A star is essentially the same algorithm as Dijkstra's, except for A star, whenever we're computing the priority of a particular node, we always add h of n to whatever you would use with Dijkstra's. So once again, we initialize all the nodes in the priority queue to infinity. Since we are starting with A, we set it to 0 and pop it off. Next, we look at the vertices A is pointing to, which are B and D. So starting with B, we see that the current path between A and B is 1. And we also see that the heuristic from B to G is 6. So our current priority for B is 7. For D, the edge weight is 2, and adding the heuristic value of 6 gives us a priority value of 8. And since B and D are both currently infinity, we update both of them. Our next node to pop is B. B is pointing to C, and the current distance along the path is 4. Adding the heuristic value of 5 to this gives us 9, and we again update the queue. We then pop D, and D is pointing to E, and the current distance is 5, plus the heuristic 3 gives us a priority of 8, and we update the queue once again. Next we pop E, it's pointing to G, and the current path distance is 8. Since this is our end goal, we don't have heuristic value, and we are done. So the shortest path from A to G is from A to D to E to G.